Hello everyone, welcome to the solution of LeetCode problem 1020 named number of enclaves. Here we are given a two-dimensional matrix which contains the value 0 and 1, where 0 represents water and 1 represents cell. Now here we can move from any cell equal to 1 to any other cell equal to 1 in 4 directionally. That means either I can move up, down, right or left. Now we have to return the number of land cells in the grid for which we cannot walk off the boundary. So here let's understand the first example. This is a land cell which is 1. So if we move one step left, we can go out of the boundary. But these 3 1 nodes, which is this and that, by doing any number of jump, we cannot go outside because all of the surrounded cell is water. So here we can say that for this grid, there are total 3 1 in which we cannot go outside of the grid by using the jump any number of times. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken the same example. Here, there are 4 cells which is equal to 1. And the rest of the cells are the water cell. So for this cell 1, we can go either up, right, down or left. And here, up, right and down cells are 0, so we cannot move there. But if we go left by 1 move, we can simply go out of the bound or out of the region. But suppose for this cell 1, we can go up, right, left or down. So here, by moving up, right or left, we cannot go outside of the grid. Even we cannot move to the water cell. So we have to move to the downwards. From downwards, we can go either right, down, left or up. So here, we cannot go right or down. So we will go to the left. Now from left, 1, we can go either up, left, down or right, but we cannot go up, left or right. Sorry, down, because all of them are water. So we can say that in total there are 3 nodes, which is this one, and this one. They are in these 3 ones, we cannot go outside of the grid by using any number of moves. So I hope you understood the problem statement clearly. Now the question is, how can we solve this problem? We can basically solve this kind of problem by using the DFS in a 2-dimensional grid. Now, let's see how the DFS on a 2-dimensional grid work here. The intuition is very simple. We have to run a DFS call for each of the boundary cell, which is this, and this. So for each of the boundary cell, we run a DFS call, and if we find any of the 1, we have to make it 2, or we have to make it visited. So here, by doing so, suppose this 1 and this is 1, so we have to make this, both of them 2. That means we can move from this node to the outside, and we can move from this node to the outside. So the basic intuition is we have to run DFS into the boundary cell, and we have to make the element which is 1 equal to 2. After that, performing the DFS, we have to check how many number of 1 presented in the grid. So here we can see that there are 3 1 presented. So we have to print 3 as the answer. This is the basic intuition. Now here, let's modify this example to understand the problem little bit of clearly. Let's make this 1 and let's make this 1 and let's make this equal to 1. So in total there are 1, 2, 3 and 4 no value which is presented in the boundary and equal to 1. So if the DFS call start from this 1, we can go up and make it visited, and we can go right and make it visited. So all of them is equal to 2. Similarly, if the DFS call start from this 1, we can make it visited, but from this cell we cannot go any of these 4 direction. So here we can see that after completion of the DFS, there are 3 1 remaining into our grid. So we can say that in total there are 3 cells from which we cannot go outside by any number of jump. And if we can go outside by any number of jump, that means this node value 1 has a path to its any of the boundary cell which is equal to 1. So this means we can jump from this one, and from 1 we can jump from outside. So this is the basic intuition. In short, we have to run a DFS for each of the boundary cell and mark each of the cell which is land, make it visited or equal to 2. After that, we have to scan each of the element into the grid, and we have to count the number of 1 presented. And this number of 1 means that we cannot make this land 1 visited from any of the DFS call. So it is not possible from this 1 to jump out of the box or out of the grid. And finally, we have to return the number of 1 presented in the grid. And overall time complexity of this algorithm is big O of n into m, where n is the number of row and m is the number of column into this grid. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named number of enclaves, and we are calculating the dimension, which is n and m. So for each of the row, we have to call the DFS into the first column and into the last column cell. Similarly, this loop will call the DFS into the first row and into the last row cell. And inside the DFS function, if our current ij becomes out of bound, that means I or j less than 0, or I greater than or equal to n, or j greater than or equal to m, or grid of ij is equal to 0, that means it is water cell, or grid of ij is equal to 2. That means this cell is already visited. We have to return. Otherwise, we have to mark the grid as visited and recursively call the DFS function in to its 4 direction, which is I, j plus 1, I, j minus 1, I plus 1j, and I minus 1j with the same grid. Finally, we have to scan each of the element of the grid, and if the grid element is equal to 1, we have to increment the answer. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.